28 centimeters. Grab a standard school ruler in your mind. That tiny amount of space is the terrifying reality right now at Cobb, which is a massive choke point on Germany's Rhine River. Water levels there have literally collapsed to an unprecedented and, frankly, dangerous low. To put that into perspective, a fully loaded cargo barge navigating the Rhine usually needs well over 2 meters of clearance just to safely pass through without scraping the bottom. Compare that to 28 centimeters. It's creating this instant heart-pounding tension for every single logistics company in Europe that tracks this waterway day in and day out. Welcome to The Explainer. Today, we're unpacking the Rhine River crisis. What looks like just a localized dry spell is actually the first domino in this massive hidden chain reaction. We're going to uncover how a lack of rain in Central Europe is tearing through logistics and threatening to severely fracture global supply chains. It is a fascinating and honestly alarming domino effect. Here's how we'll break this down today. First, a look at the disappearing waterway itself, then the logistics nightmare it's causing, why the continent is running dry, the resulting energy security threat, and finally asking if this is our new normal. Okay, part 1, a disappearing waterway. Let's look closely at that critical choke point at Cobb. The numbers we're seeing are just staggering. Right now, the usable depth of the shipping channel at Cobb is sitting at just 1.43 meters. But a large, fully loaded goods vessel, that requires a minimum draft of 2.8 to 3.5 meters. And some of the truly massive ships need a full 4 meters. Because of that massive gap, ships are being severely curtailed. They're forced to run at half or even a quarter of their normal capacity just so they don't run aground. Imagine trying to run a profitable, large-scale delivery network where your vehicles are only allowed to be a quarter full. The reality on the ground is stark. As industry experts are pointing out, 28 centimeters is not just a yellow warning flag. It is barely enough water to float an empty hull, let alone one carrying thousands of tons of coal or diesel. And the forecast? It's incredibly grim. Hydrologists expect levels to drop to 24 centimeters within days. If that happens, it shatters every single record since detailed tracking began 36 years ago. We are literally in uncharted territory here. Which brings us to part 2, the logistics nightmare. What does a dry riverbed actually mean for an 800-mile waterway that acts as the backbone of continental trade? Well, it means the fundamental math of shipping is completely broken. To move the exact same volume of coal, chemicals, and diesel that the Rhine normally transports, companies suddenly need 3 to 4 times as many trips. Think about that. You're taking a finely tuned logistics network and suddenly demanding several times the capacity, but you only have the exact same limited number of vessels and crews. It's mathematically impossible. You just can't squeeze 4 times the traffic into the same tight corridor without causing a catastrophic bottleneck. Now, I know what you might be thinking. Why not just put all that cargo on trains or trucks? The problem is there is no fast substitute waiting in the wings. Moving heavy cargo by water is dramatically cheaper, wildly more efficient, and operates at a scale that is honestly hard to comprehend. The rail and road infrastructure across Europe was simply never built to overnight absorb the massive, heavy-duty volume that the Rhine handles every day. Trying to shift that huge burden just triggers massive delays and instantly clogs up highways and rail lines everywhere. So let's trace exactly how this broken supply chain reaches directly into your wallet. Step 1, barges are curtailed because of the low water. Step 2, that suddenly reduced capacity causes diesel shipping rates to spike to absolute record highs. Step 3, this massive extra cost is absorbed by refineries and distributors who are just desperately trying to move their product. And step 4, that cost is passed directly to the consumer. This means prices jump at the gas pump and on everyday goods manufactured across Germany's industrial heartland. This isn't just about ships stuck in the mud, it's about the escalating cost of daily life. To really understand why this is happening, we have to look beyond the Rhine itself. Let's move to part 3, a continent running dry, to examine the broader environmental root causes. We are actually watching 3 massive water reserves fail simultaneously: aquifers, lakes, and crucially, alpine snowmelt. Usually, snow melting from the Swiss Alps acts like this amazing timed release valve. It feeds the Rhine well into early summer and naturally sustains those water levels. But this year, that snowmelt dried up months ahead of the typical cycle. The reserve tank is completely empty far earlier than anyone planned for or built infrastructure to handle. At its core, this is what scientists call a hydrological drought. This isn't your standard flash drought caused by just a couple of hot, dry weeks. No, a hydrological drought is a slow-building disaster. It means deeply stored water sources, water that took years, sometimes decades to accumulate, are being drawn down way faster than they can ever be replenished. Extreme heat and a near total absence of rainfall have slowly, systematically starved the whole ecosystem from the groundwater up. And the data from the European Commission reveals the staggering scale of this. 44% of the EU and UK are currently exposed to drought conditions, with another 9% already in severe alert status. Less than half the continent is seeing normal conditions right now. And the Rhine is definitely not alone in this. The mighty Danube has plunged to 30-year lows, and the Loire River in France has literally been reduced in some places to a dry bed with just scattered muddy pools of standing water. It's a continent-wide evaporation. Now we reach the most critical juncture. Part 4, the energy security threat. This drought is colliding directly with international energy systems to create a massive geopolitical squeeze. What makes this moment so dangerous is how these system failures are compounding. Think about it. It's not just barge traffic being constrained. At the exact same time, nuclear power plants in France are struggling to stay online because they literally lack sufficient cool river water for their reactor cooling systems. Meanwhile, dry-baked soil across Italy, France, Spain, and Germany means agricultural harvests are tightening drastically. When independent systems, transportation, power generation, and our core food supply all start failing together under the same heat, it signals that the underlying pressures have crossed a dangerous threshold that modern infrastructure just wasn't designed for. Which brings us to the ultimate geopolitical stress test. Back in the spring and summer, the drought hit early, severely constraining river-based fuel deliveries. To fill that huge energy gap right now, several European nations have absorbed massive amounts of liquefied natural gas, or LNG, from Russia's Yamal facility. But mark January 1st on your calendar. The European Union is set to ban those Russian LNG imports. So Europe is relying on a safety valve that is about to be completely shut off, right as river capacities remain severely weakened. It's two vital supply routes tightening at the exact same time, creating an unprecedented energy squeeze heading into the colder months. With infrastructure failing and geopolitical safety valves closing, we have to look ahead. Part 5. The new normal. How does the global supply chain possibly adapt? Well, the immediate hurdle is what we call the fleet paradox. Most vessels operating on the Rhine were built decades ago, designed for historical, predictable water levels that, frankly, just no longer exist. Now, specialized, shallower draft, low-water ships do exist, but they are very rare exceptions, mostly owned by just a few forward-thinking German ship owners. You can't just call up a shipyard and order hundreds of new, redesigned barges overnight. Building an entirely new, climate-adapted fleet takes years of capital and labor. The harsh reality here is that the shipping industry currently has almost no tools to adapt quickly to a crisis unfolding in real time. The industrial inertia is just too massive. Which leaves us with this final, really vital question. What if this is the new normal? If the most important waterway for European trade can be brought to its knees by a single summer of extreme heat, what happens to our global supply chains if heat waves and absent rainfall become the standard rather than the exception? It's a systemic vulnerability we absolutely can no longer ignore. Thanks for joining me on this deep dive into the Rhine River crisis. Keep questioning, keep learning, and I'll see you in the next explainer.